Early last year, we redesigned the Buffer homepage, and I want to show you how we went from this to this. But the path to get here wasn't straightforward. When we first redesigned the page, our priority was getting the new design language in place and emphasizing that Buffer could connect to many social media channels. This looks a little bit broken because we're using Wayback Machine, but the first pass of the redesign was to emphasize that you could post your content everywhere. So these images should have transparency, but you can see that we basically just had a subtle parallax effect as you scrolled, and the feature sections below grew in size and emphasized the images as they came into the viewport. This iteration felt a little too plain and wasn't directly communicating how many channels Buffer supports. So a couple months later, we released another iteration of the homepage hero. This time we had this scrolling feed of all the channels that Buffer supports, talking about building your audience on various channels. And while this did a better job of communicating what Buffer could connect to, it also felt a little plain. So we pushed ourselves further in terms of communicating how many channels Buffer supports, but also wanting to explore animation and interaction further. And this is the version that's still live to this day. So we have the various social media channels, as well as emojis to evoke the reactions you get on social media. And as you move your cursor around, each of these floating tiles that are typically arranged on a grid follow your cursor around and react to what you're doing. Now, the design engineering process for this wasn't the most straightforward process, but it comes with a lot of cool techniques and things I learned along the way. The first thing I wanted to tackle is how do we get this effect of a tile being pulled towards the cursor as you move around the page. To achieve this, I created a prototype with just a single tile. And this prototype proved out the functionality that when the cursor enters a certain range within the tile, it's going to be pulled towards it and animate smoothly with a spring animation. And here's the code for a single tile. Let's call it an animated tile. This uses the React Motion animation library. And what we're doing is first checking if the user prefers reduced motion. If so, we're going to skip this animation entirely. If they do allow motion, then we're basically going to create a spring animation. What we need to do is track the position of the mouse cursor, X and Y coordinates, and then we're going to create a spring animation. The motion docs do a good job of explaining this, but spring animations create really smooth, physics-based animations that simulate the real world. With this, they have settings for things like velocity, damping, or basically how quickly the spring should return back to its normal length, the stiffness of the spring, and even the mass of the item that's pulling it towards a direction. So back in code, you'll see that we're setting up some of those spring properties and just a little bit of fine tuning to get the right magic numbers here. Next, we're calling use spring in both the X and Y directions. And then we're using a use effect to track the mouse move event. So with the mouse movement, what we're going to do is understand the coordinates of the bounding rectangle or the container around this homepage hero. And then we want to get the relative X and Y coordinates of the tile within that parent container. With this initial prototype, one of the issues is that the tile would follow the cursor continuously, regardless of how far away the cursor was. So to solve for this, we establish a max distance that the tile can be pulled towards, and then establish an activation radius, which is how close the cursor needs to be to the tile for it to animate. From there, we figure out the distance from the cursor to the tile position. And because this has an X and Y coordinate, we can basically take the hypotenuse of that to figure out the actual length. If that distance is within our activation radius, so within 400 pixels, and the distance is less than our max distance of 35 pixels, then we're going to basically establish how far the tile should move. If the distance between the mouse cursor and the tile is greater than our max distance, then we want the tile to still be pulled in the direction of the cursor, but respect that maximum boundary. And if the distance of the cursor exceeds 400 pixels for the activation radius, we simply want the tile to return to its original position smoothly. So with that in place, we can interact with the live version, and you'll see that as the cursor approaches a tile, it starts being pulled in the direction, but it also has a max distance. So here, this X icon is still being affected by the mouse cursor, but as soon as it moves far enough away, it'll return to its resting position. And so combining this effect with many animated tiles, you get this sort of gravity effect as you interact with the page. The next big challenge was figuring out the layout and positioning of these tiles, especially across all breakpoints, as well as the visual grid lines that you see in the background. This was done with a mirrored layout that has a grid on the left and a grid on the right. And within this grid layout, we have some nested grids that establish the columns and rows for each of these tile cells. And if we turn on the CSS Grid overlay in DevTools, you'll see that we have the tile cells established with auto-scaling rows and columns using CSS Grid. So here in our CSS styles, we have a decorative grid container, and we want to track the tile size. In this case, it's 3 rems. And we have slightly smaller tiles for the emoji tiles in the background. This decorative grid is basically absolutely positioned to span the constraints of the full hero section. And next, you'll see that it has a parent grid layout of a simple 2-column layout that establishes the left and right portions. And at a larger breakpoint, we simply increase the tile size. Next, with our nested decorative grids that would establish the leading and trailing sections, or the left and right sections, we have autofill grid columns and rows that are going to grow to the established tile size. So this is what establishes the cell dimensions and allows this to be fully responsive. And if we turn on responsive design mode within DevTools, you'll see that the grid cells gracefully scale based on the available size. One of the challenges of this approach is that each of the grids wants to be left aligned by default, because the writing direction for English is left to right. So you'll see that this first grid grows from left to right and leaves any remaining space on the right edge. And this leaves an unwanted gap in the middle, which causes the layout to not be symmetrical as we want. To solve for this, we're first establishing that the grid container has a writing direction of left to right, and this is the default, but we're explicitly setting it here to prevent the user agent writing direction from affecting the decorative mirrored layout. Then down below, in our leading section, or the section off to the left, we're going to switch the writing mode to right to left. And what this does is allows it to allocate that unused space if it's not perfectly going to fit another grid tile into the left side, which allows us to have a perfectly mirrored layout. So with that enabled, we now get rid of that unwanted space, and our grid columns now count out from the center. So on the right grid, you'll see that we have 1, 2, 3, 4. On the left grid, you'll see that from the center, we're going to the left to increment our column count. So with that mirrored layout in place, we now have the problem of how do we position these tiles within the available cells. Since we're counting from the center, I created a CSS variable called column from center to establish how many columns from the center of the viewport we want the tiles to be placed. And that'll default to 0. So with that CSS variable in place, we can go to each of our tiles. If we look at the markup, there's a number of tiles within each decorative grid. So we have animated tiles for the emoji and quite a few of those. And then on a layer above that, we have our animated tiles for the channel logos. And with each of those, we're going to count how many grid rows down we want from the top, as well as what column from the center we want to place those on. And it's pretty tedious, but we have to basically gradually increase the viewport and redeclare any tiles that need to shift to accommodate and not overlap with the text content. And quite a lot of exhaustive positioning to get a fully responsive design. And again, in responsive design mode, you'll see that as the viewport increases, the tiles are going to jump to new positions to not compete with the content, and we'll gradually introduce more and more tiles until we reach a maximum viewport that can accommodate all of the tiles needed. Lastly, let's cover some of the finer details of the visual design here. So there are very subtle visual grid lines in the background, and those grid lines fade around the edges of the hero section. Additionally, the emoji tiles are smaller and have a blur to tuck them into the background and create a depth effect. This is achieved with a simple CSS blur and turning down the opacity. And as we established earlier, the emoji tiles are 75% of the normal tile size. The grid lines here are very subtle, so let's increase the opacity for now, just so we can look at how it works. I'm going to change this grid line color variable, and now it should be really evident what the visual grid lines are achieving. And you can see the subtle fade that we have around the edges as well. The grid lines themselves are basically just repeating linear gradients. So on the left half, we have our fades, which we're going to talk about in just a second. And then lower down, we have our gradients that establish the left and bottom strokes that establish a visual grid line. On the trailing section, which is the right half, we do the same thing, but we establish the right and bottom grid lines. And since this is a repeating linear gradient, when you combine that with the same grid cell size, we get this visual grid. And if we combine that with a couple other linear gradients, one that goes towards the top, going from 0% opacity with our background color to 100% opacity, and another that goes towards the sides for a subtle fade off, we get this nice drop off of the visual grid lines. With our grid line color restored, we can now see the finished effect. So there are a lot of fine details going into the design engineering of this section. And as I mentioned, this is our third iteration after the redesign last year, and it probably won't be our last. But hopefully there's some interesting animation, interaction, and layout techniques that you can use in your own projects. If you have any questions about how this was built, or you want me to go into more detail, feel free to ask in the comments, and I'll be responding there.